Hello students, in previous part you have learned about the operations on matrices. One of the operations that we are going to talk about is determinants. So we will start in this part what determinants are and how they are calculated. So first of all, we need to know that what are determinants. Okay, so determinants play an important role in finding the inverse of a matrix and also in solving system of linear equations. So determinants of a square matrix is a number which is associated to the square matrix with a certain algebraic expression. The determinant of a matrix will be denoted by det of A or mod of A. Now out here there are three things written together. Let me elaborate it for you a bit. See, determinants is a part of when we are solving system of linear equations, we need to know the determinants first, and it plays an important part in solving a system of linear equation. Whether initially we need to solve it or not, it plays an important part in that as well. You know that if we wanted to solve a system of linear equations, and we can proceed in solving a system of linear equations. So first of all, if we find out what the determinant of that particular system, we will be able to understand that okay fine, we can now proceed with its further solutions. Okay, so determinant plays an important part. Also, it's written that determinant of a square matrix. Now it's a very important thing that determinants are only calculated of a square matrix. Now what square matrix is? A square matrix is those matrices that have equal number of rows and columns. So specifically the thing written out here is a square matrix. So that means that determinants are only associated with square matrix. Okay, so now it's written that the how it is denoted. It's actually denoted by this det of A, det of A, or mod of A. This is the common expression that is written everywhere when we need to calculate determinant for a matrix. Okay. So first of all, before calculating determinants, we need to know that what are singular and non-singular matrices. Now why I have included this topic, it is because when we will be solving linear equations, so we will be calculating determinant first, which will be a first part. Okay, so if determinant, there are certain values for determinant that if that case appears, we have to take a decision at that point that whether we need to proceed further or not. Okay, so for that we need to know that what are singular and non-singular matrices. Now singular matrix is a square matrix whose determinant is equal to 0. Okay, modulus of A is equals to 0. Non-singular matrix is also square matrix whose determinant is not equals to 0. Okay, now see, determinant of a square matrix, we have learned earlier that determinants will only be calculated of a square matrix. Okay, now if a determinant is equals to 0, that means that we cannot further solve it. Okay, now why we cannot further solve it, we'll just see this in my next in the next part of the course, where you'll get to know that why determinants are important, and if determinant is equals to 0, why we should not proceed further. Okay, so we always work on non-singular matrices. Now non-singular matrices are those matrices whose determinant is not equal to 0. So we need to avoid this 0 situation in determinants while we are solving system of linear equation, or when we are solving we are taking inverse and all. Okay, now in this particular part we will be discussing how to find out determinant of order 2 and of order 3 matrices. Okay, so the first thing is that we need to know determinant of order 2, that how to find out determinant of order 2 matrix. Now order 2 means what? There should be 2 rows and 2 columns, right? So since it is already said earlier that determinants will only be calculated of a square matrix. So first of all, the first thing is that we are going to learn is how to calculate a determinant of order 2. Assuming A is an arbitrary 2 by 2 matrix, assuming A is an arbitrary 2 by 2 matrix A, where the elements are given by this. Okay, this is a general arbitrary matrices. Now it's the general transformation of a matrix. Okay, then the determinant of this matrix is as follow. Now out here I have written that if A is any matrix which has any elements, those elements can be any elements. Okay, so if in calculating an determinant of order 2, now how we will be calculating it? See, the matrix sign out here is now turned into these straight lines, right? Not those rectangle brackets out here. These are now straight line. We are defining, we wanted to find out this particularly, this symbols are used for finding determinants. Okay, when we okay, first of all, let me tell you this thing. In mathematics, symbols work accordingly. Okay, like this, if you're solving matrices, now this modulus is actually telling you to find out the determinant, and it may act differently while we are calculating something else. So it happens, it is possible. Okay, so let's first of all focus on determinants. Okay, now determinants, now see what I have done is that I have rewritten those arbitrary numbers. Those numbers can be anything. I've defined it with A. Okay, and these are the position written. Now if we need to find out the determinant for this matrix, okay, what will be the procedure? We will cross multiply the elements of the particular matrix. Now A11 will be multiplied by A22. Okay, the sign we will follow is minus, and A12 will be multiplied by A21. So it's a cross multiplication. See, this cross, the first diagonal elements will multiply together. Okay, and then upper and lower triangular multiply together. It's like, you know, it's a cross multiplication. Cross, these two elements multiply together and these two elements multiply together, the sign in between will be negative. Okay, so here is an example. So it's written, find the determinant of the matrix. The matrices, the elements are 2, 4, 8 and 6. Okay, so we need to find out its determinant. Now what I have done out here is I've rewritten it. Okay, and then 2 cross multiplication, as I said earlier, 2 into 6, 4 into 8, the sign in between is minus. So as you can see, I have multiplied 2 into 6, sign in between is minus, and then 4 into 8. So the result is 2 6 is the 12 minus 32 minus 20. Now minus 20 is a non-singular element. Okay, 0 shouldn't be there. If it's 0, then determine it's a non-singular matrix. Sorry, if there is 0, it is singular matrix. Now except 0, it can be any number. Okay, any number, but it shouldn't be equal to 0. Moving on, we are moving on to the determinant of order 3 now. Okay, so assuming A is an arbitrary 3 by 3 matrix A, where the elements are given by, now this is basically a 3 by 3 matrix. As you can see, all the elements out here are listed here. Okay, A can be, small a is any, you know, any number. These are the positions defined. As you can see, 1 comma 1, 1 comma 2. Then the determinant of this matrix is as follow. See, when we are solving a 3 by 3 matrix, as we have seen earlier, determinant of 2 by 2 is very easy, right? So what we are going to do, then we're going to break this 3 by 3 matrix into a 2 by 2 matrix first, and then we'll calculate its determinant. Okay, so it's a 3 by 3 matrix right now. What I'm going to do is, Then I'm going to break it into a 2 by 2 matrix first, and then we'll solve its determinant, or we'll find its determinant. How it's done, let's see. Okay, now determinant of it, this is basic symbol that we used to do. Next step will be, okay, I'll rewrite it again. Okay, now as you can see in this particular step, I have expanded it by using R1. You can expand this matrix by column 1, column 2. It's completely up to you. What we have done is that I've decomposed it using R1. Okay, I've used this R1 through this thing, through this R1. I have break this 3 by 3 matrices into a 2 by 2 form. Okay, now as I said earlier that I'm going to process it in a 2 by 2 matrix, and then we'll solve this its determinant, because we have seen earlier that 2 by 2 matrix solution is comparatively easy. It's easy to solve. So when we are dealing with a 3 by 3 matrix, we're going to follow this procedure, that we're gonna break it in a form, in a 2 by 2 form. Now when we are doing this, obviously we need to know, or we need some restrictions, or there should be like a method of doing it. Now out here, what we have done here, see, we can go back. I have done is that I've expanded it by using this first row. Now as you can see, when I've done this, now you can use first column as well. Okay, it's not necessary that you always use first row. You can use first column, second row. I need to tell you how it works, right? So what we have done is we have fixed this first row. Let's consider it as like we have fixed this first row. Then we start composing it into a 2 by 2 form. Now how we do it? Selecting this element, okay, as a scalar. Now you can say, but it's not actually, it's element A11. Now this position, okay, this position, now we need to break it into a 2 by 2. Now how we do it? See, this was first row and first column. Now we are going to use the subscripts out here. First row, first column. Okay, that means we need to hide first row, first column. The remaining are now a 2 by 2 form. I have now become a 2 by 2 form. If I hide this row and this column, first row and first column, I will get all the elements. I'll get 4 elements, and then eventually turn into a 2 by 2 matrix. See, first row hidden, first row hidden, and first column hidden. What is left? A22, A23, A32, and A33. Okay, now the sign is alternative. The first was plus, minus, and then plus. Okay, now A12. Now A12 is what? First row, second column. So we're going to hide first row, second column. What are the elements left? A21, A23, A31, A33. Now as I said that the sign will be alternative. So plus, minus, now it will be plus. Now this is 1, 3. 1, 3 means what? First row, third column. You're going to hide first row, third column. What will you get? A21, A22, A31, and A32. Now if you're working according to the first column, so if you hide first column, right, if you fix the element for first column, so what will be? For first element A11, you'll hide first column, first row. These will be the main elements. A21, 21 means what? Second row. You're gonna hide second row and first column. The remaining elements will be 1, 2, 1, 3, 3, 2, 3, 3. For 3, 1 means what? Third row, first column. So out here we're going to use these subscript, these position values. 3, 1, third row, first column. Now these are the elements left. Now let's just consider an example and understand it better. Okay, this is a matrix A which has element 1, 2, 4. 5, 7, 8, 6, 4, 3. Now for determinant of A, what I've did is that I've fixed the first row and I'm expanding it through R1. That is my first row. 1 determinant. See, first row, first column. 7, 8, 4, 3. Here you go. Then the sign alternative is minus, right? 2 as it is. 2 stands here, right? So 2 stands here means that we're going to hide first row. We're going to hide first row and second column. 5, 8, 6 and 3. Alternative sign plus, minus and then plus. That means 4. 4. First row, third column. 5, 7, 6, 4. Now what you're going to do is that, see, we have learned earlier that how to find out determinant of a 2 by 2 matrix. We do cross multiplication. 7 into 3, middle sign is minus. 8 into 4, there you go. Minus 2 as it is written. 5 into 3 minus 8 into 6, plus 4 as it is written. 4 into 5 and 6 into 7. The middle sign is minus. Now see, what I've done is that I've used some basic arithmetic algebra and I've calculated it, and the result are minus 11 minus into minus 66. Now what I did is that I have multiplied it, subtracted and then multiplied it by 2. The final answer what I got is minus 66. Okay, plus multiplied, subtracted, multiplied it with 4, and the result I got is minus 88. So now what I'm going to do is this minus 11, minus into minus is plus, plus into minus, minus 88. Now the answer you got is minus 33. Okay, these are the following questions that I want you all to attempt in order to understand this thing better, so that if you understand what determinants are, we can move further for inverse of matrices and to find to solve the system of linear equations, that which actually is our main goal. Okay, so I would request you also just solve it, and if you have any queries, the answers are given right here. So do solve it, and I hope that you have understood this part. Hopefully we'll learn more about determinants and why they were important in my next part. Thank you so much.